geometry notes. I think that's on page 7. Okay, we will take reference to this page whenever we do any proof of your geometrical properties of quadrilaterals. Okay, so maybe I run through with you what does this actually tell us first. Okay, there are several ways for us to go about proving the different types of quadrilaterals. It need not always be by the definition itself. For example, our square, our understanding of the square, we know that it is always 4 equal sides and the interior angles must be 90 degrees, must be right angles. That is the definition. Okay, but certain times, okay, when given in the question, they don't provide you sufficient information for us to stick with this definition to prove. So therefore, we have equivalent conditions that will allow us to actually show that it is also a square. So for instance, okay, the second point here, on diagonals being equal and bisect each other at right angles. So if you're able to show that the diagonals here, BD and AC, are equal in length, and also that they bisect each other, that means that X is the midpoint for AC and BD. If you're able to do that, and one more point is the right angle part, okay, then it actually naturally tells us that it will be a square as well. That is what it means by equivalent conditions. Okay, so out of these 4 points, just choose one to use it to actually go about proving. You may find that this is very overwhelming. Okay, how am I supposed to go and memorize every single thing? Okay, naturally, as you do more proofs, okay, you will find that certain points are very often used. Okay, so for example, for parallelogram, they often ask us to prove parallelogram. So you may want to highlight, okay, that usually instead of talking about 2 pairs of parallel opposite sides, okay, very often we make use of this equivalent condition to prove parallelogram. Okay, the very 4th point. Has 1 pair of parallel and equal opposite sides. Okay. For the rest, usually our definitions, our understanding of the definition will work. Okay. So the definition are namely the very first bullet point of each quadrilateral. Okay. We can only prove using the conditions over here. Okay, we cannot use the properties on the right side to prove because they are not sufficient, they are not complete enough, okay, to tell us that it is going to be like a rectangle or square. So for example, for rectangle, okay, it has parallel opposite sides. This is a property of a rectangle, but if you only show that there are parallel opposite sides, it can always be a square, it can be a rhombus, it can also be a parallelogram, right? Okay, so that's why we cannot use properties to actually go about proving. It is not sufficient. We need to be very specific when it comes to quadrilateral proofs. Okay. So just to maybe explain how is it that they are equivalent conditions, right? Okay, so just now I was talking about this diagonals being equal and bisect each other at right angles. Okay, why is it that when diagonals being equal and bisect each other at right angles can tell us that it must be a square? Okay, so I'm just going to roughly, briefly bring you through it up. So when the diagonals are equal and they bisect at right angles, right? Okay, we notice that this length and this length over here are the same. And down here will be 90 degrees, or rather, looking at this triangle, we have 90 degrees. In other words, this is a right angle triangle. Okay, so that means that by Pythagoras theorem, I can go and find out what is the length of AD if I know the length of AX and XD. Okay, so notice that this triangle is actually congruent for the other 3. So naturally, this length will be equal to this, will be equal to this, will be equal to this as well. Okay, and therefore it must surely be a square. You understand? Okay, so that's why you don't need to go for the extra steps by using your Pythagoras theorem and all that to prove towards the 4 equal sides and 4 right angles. Proving up to this stage is already sufficient. It is an equivalent condition. Okay, so that's the reason why we have these equivalent conditions. Okay, I'm not going to run through every single one. Okay, you will realize it when we practice questions. Okay. And they're not going to ask you for every single quadrilateral. Okay, often is usually a parallelogram. Right, so let's look at example 6. Okay, so in example 6, right, it says that the diagram shows a quadrilateral ABCD with AD equals to BC and AD is parallel to BC. Okay, the question did not mention that this is a parallelogram, so you cannot make an assumption that it will be a parallelogram. However, even if the diagram looks like a parallelogram, you cannot assume it so long as the question did not mention it. You must prove it if you want to make use of any of such properties. Okay, so in part I, we want to show that triangles ADB and CBD are congruent. So ABD is the triangle on the top half and CBD is the triangle in the bottom half. Okay, so in order to prove congruency, maybe we can look for the angles first. Okay, so we see that we have alternate angles over here and here. Okay, and then we also have this side that is actually the same. Okay, then if you really need some help in terms of orientating the triangles, you may want to draw it out. Okay, two that are congruent side by side, just for visualization purpose. Okay, so this is ABD. Following the naming, ABD, this must be CBD. Because we know that the vertices must correspond. Okay, I know that AD is equals to BC, CBD, ADB, CBD. I bet. Okay, so AD is given to be equals to CB, and then we also already know that alternate angles allows us to have this angle equal to this angle. Okay, and we observe that BD is actually a common side. Okay, so always have a plan first before penning down your proof. So we will be actually making use of SAS test. So we see that the SAS test will help us to show that the two triangles are congruent. We look at part 2. We want to prove that AB is equals to DC and AB is parallel to DC. Okay. So from part I, since we know that the two triangles are congruent, naturally we can conclude that AB will be equals to DC. But the problem that we face is that how do we actually go about proving that AB is parallel to DC? Okay, because congruency doesn't tell us anything about parallel, or rather parallel lines. Okay, it doesn't actually lead to having parallel lines at all. Okay, so what we can do is that we observe that right at the start of the question, it has already mentioned that there is one pair of equal sides and one pair of parallel lines. Okay, and that is actually an equivalent condition for your parallelogram. Okay, which is the one that I asked you to highlight earlier. Right? This one here. Okay, so having one pair of parallel and equal opposite sides, okay, it will lead to a parallelogram. So that is what we can conclude just from the information that has been already given. One pair of parallel lines, one pair of equal sides, it will have to be a parallelogram. Okay, so since AD equals to BC, while you need not write down any reason, I'm just going to state here for your own note-taking purposes that it is because of this condition. Because we are able to prove that it is a parallelogram, then naturally the properties of parallelogram will actually follow, whereby AB must be equals to DC and AB must be parallel to DC. Okay. Information that will be helpful. It says that in the diagram, ABCD is a quadrilateral. A quadrilateral is just any four-sided diagram. Okay, and EFGH are the midpoints of the sides AB, BC, CD, and DA, which are already indicated on the diagram. So the midpoints EFGH are the respective midpoints for the respective sides of the given quadrilateral. The question has also mentioned the angle HEF is equals to 90 degrees, and we want to prove that the quadrilateral EFGH is a rectangle. Okay, so how do we go about proving that it is a rectangle? If you want to use the definition of a rectangle, that will mean that EF must be equals to HG, EH must be equals to FG, but that is not the only thing that you must prove. You must also prove that the interior angles are 90 degrees. Because just by proving that they are equal in length, it only suggests that it is a parallelogram. Right? Because parallelogram does give us opposite sides to be equal in length. But then the angles, the interior angles need not be 90 degrees. The interior angles must be 90 degrees in order for it to be a rectangle. Okay? But then, if you want to make use of the definition, it might be a little bit challenging because how do I transfer the fact that this is 90 degrees, this information here, over to this side, over to this side, over to this side? Because the thing is that the question did not tell us that EH is parallel to FG. Because if EH is parallel to FG, then it is convenient that we can use interior angles, okay, parallel lines property, whereby 180 minus 90 will naturally tell us that this is 90 degrees. You understand what I'm saying? Okay, so maybe we should not be using the definition to go about proving this. Okay, so how do we go about proving this? We will make use of the fact that, okay, we can show that EFGH is a parallelogram, and then just with one angle being 90 degrees, okay, then naturally everything else will follow already. Okay, so we will use the equivalent condition. Let me bring you back here. Okay, we are going to make use of this part here. We will show that it is a parallelogram with one right angle. Because we know that once it is a parallelogram, okay, and one of it is a 90-degree angle, then interior angles parallel lines property will follow, telling us that this must be 90 degrees because this is a pair of parallel lines. And over here, it being a pair of parallel lines, this will also be 90 degrees because of interior angles parallel lines property. So that's why we can just simply stop our proof by after we have shown that it is a parallelogram and there's one right angle. Because naturally the rest of the steps will follow itself. We don't need to go about insisting that it must be a parallelogram and then having four right angles. Okay? So let's write down the proof. Okay? So how do we even prove that EFGH is going to be a parallelogram? Okay? The question gave us that they are midpoints. So when you see midpoints being given to us, you think about the midpoint theorem. Okay? So midpoint theorem relies on triangles. Okay? So we will look at this triangle first. Oops. Okay? Whereby because E and F are actually midpoints of the respective sides, we know that EF must be parallel to AC. Okay, we have done this earlier on in our last lesson, something similar to this. So if I'm able to prove that EF is parallel to AC, when I look at the other triangle, I can also use my midpoint theorem to see that HG is parallel to AC. And therefore, we see that EF is parallel to HG. Okay? Not only that, this is half of this. This side is also half of this. So actually, EF is equal to HG also. So having one pair of parallel lines and one pair of equal opposite sides, we can say that EFGH is going to be a parallelogram. Okay? Trying to be easy. over here, whereby I prove one set of things first and then another set. And then from the two sets, I get certain information which leads to this in a summarized version. And therefore, we have our parallelogram. So it's always having the evidence, then the conclusion, evidence, then conclusion. Okay, so we always follow such a structure when it comes to proving. Okay, or at least proving at this level, we will follow such a structure. Okay, when you go up to higher levels, especially at university, there are other proving methods as well. Okay, and then in JC, you also find other proving methods. Okay, then therefore it leads us to having our parallelogram and our angle HEF being 90 degrees, hence we have our rectangle. Okay. Alright, let's look at example 8. Okay, I'll show you how part I is being done, then part 2 I'll let you try it later on. Okay, you need to get your hands dirty for proving as well. Okay, so in the diagram, ABCD is given to be a rectangle, and then angle ABE is equals to angle CDF. So those are given information to you. Okay, we want to prove that triangle ABE is congruent to triangle CDF. So to help us visualize, you may want to also again draw your triangles. Okay, so we have ABE, and we want to show that it's congruent to CDF. Okay, so with the given information, we know that this and this are equal in length. Okay, then other information we have in order to help us to prove that it is a congruent, they are going to be congruent. Okay, so because the question said that ABCD is a rectangle, very least we will know that AB must be equals to BC. Okay, because of it being a property of rectangle. Okay, the opposite sides must be equal. So that's something that we will know. Okay, then another property that we can get out of it being a rectangle is that this must be 90 degrees and this must be 90 degrees as well. So we know that this is 90 and likewise this is 90. Okay, so we go in search of your evidence first. Okay, so in case any of you want to be police officer, you must search for evidence before you can charge people. Okay, so therefore, now that we have all the evidence laid out, we know that we have AAS property being, or rather AS test being fulfilled. Okay, and therefore we can prove our congruency. And we'll write that down now. Okay, since angle ABE equals to angle CDF that's given. Opposite sides of rectangle and interior angles of rectangle. Okay? And therefore we can conclude that the two triangles are congruent. Your AAS test. right, you have problems remembering your congruency test and similarity test. Okay, you don't know how many A's, how many S are there for the respective thing because there are similar acronyms for both your congruency and similarity test. So maybe if I were to go back to your triangles page, okay, just want to bring to your attention. Okay, maybe let your computers up. Done copying? Are you ready now? Okay, in case it never occurred to you, I just thought I'd just share with you. Okay, when it comes to congruent triangles, we must know that SSS tests will apply, and then AAS, SAS, and RHS. Okay. Then your similar triangles, okay, it doesn't have your AAS test. Okay, you have your AA similarity, it has SAS similarity, which overlaps in acronym to this SAS. Likewise, for similar triangles, we also have your SSS similarity, but then that is by proving that they are proportional in size. Okay, so for similar triangles, we must know that they are proportional, the corresponding sides are proportional. So because we always want to prove that, because we always want to prove that the corresponding sides are proportional, therefore we always need at least 2 pairs of sides. You realize that? Okay, because we are always trying to prove that this pair is equal to this other pair in terms of its ratio. So because we always need at least 2 pairs, right? That's why similar triangles must always have at least 2 S if you're going to ever involve any S. Okay, any sides itself. Right? You can never have AAS test because AAS is only one side. Just having ratio of 1 pair doesn't tell us anything. Right? Okay, so I hope that realization will help you to remember better, okay, whether AAS is even a test for your similarity or not. Okay, so for similar triangles, there must always have at least 2 S's. Okay, there can never be only 1 S. Right? So that is what I wanted to say. Okay, now part 2, we want to show that EBFD is a parallelogram. I want you to give this a try. Okay, we are going to make use of, the hint is that we are going to make use of the congruency that we have earlier on already. Okay, and the biggest hint I'm going to give you is that we will use the 1 pair of parallel lines, or parallel and equal and parallel sides. Okay, we will use this property, okay, or rather equivalent condition to prove that it is a parallelogram. So how are you going to find 1 pair of equal sides and 1 pair of parallel sides? They must be the same, okay, cannot be 2 different pairs. Okay, so would I give you maybe 10 minutes, okay, go and figure this out, right? I really need your brain to start thinking and working rather than seeing how I do it, because seeing me do is definitely much easier than doing it yourself. Okay, give you 10 minutes to think about this and write home.
Oh ya, no le cuenta esta although he was very sure.
Okay, let's go through. Alright, I saw some of your proof. Okay, some of you, your proof needs a little bit more clarity. Okay, so how do we go about proving it? So I said that the pair is going to be ED and BF, right? So we need to show that they are going to be equal and also parallel. Okay, the parallel part is simple because we know that ABCD is a rectangle already. So AD will be parallel to BC. Naturally, that will also mean that ED is parallel to EF. So we can write that down first. Okay, so let's answer. Since ABCD Okay, get it out of the way. Okay. The next thing is how do we actually go about proving that ED is equals to EF? Okay, most of you can observe that because the two triangles are congruent as proven in part E. Then we see that AE is equals to FC. Okay. Then, okay, most of you also did say that because it is a rectangle, okay, your AD is equals to BC. So maybe just add this in. You can add it here. Okay. But then just because AD equals to BC and AE equals to FC, you need to have the clarity in terms of showing how is it that it leads to ED being equals to BF. Okay, so we see that ED itself is made up of taking AD minus away AE. Okay, and because we know that AD is equals to BC, we replace that, and also because we know that AE is equals to FC, we replace that as well. Okay, then BC minus away FC is equals to BF. Okay, and that's how we go about showing with clarity ED is equals to BF. Okay, you cannot give me two separate statements telling me that AD equals to BC and AE equals to FC and then say that ED equals to BF without showing to me these steps at all. Okay, you need to be very clear. That's why when it comes to proving, clarity is very important. Okay. And that's how we end up concluding that EDFD is a parallelogram. Okay. Just now Jovia was asking me, is it possible to prove that BE and FD is the pair to be involved? Okay. We can see that BE and FD are equal because of the congruency factor. Okay, but then how is it that they are going to be parallel? Alright, I am unable to see that we can show that they are parallel. Okay, I don't think there's a way for us to show it. Because usually when you want to show parallel lines, we make use of alternate angles, interior angles, or corresponding angles. Right? So because of the lack of value, okay, given for the angles involved, right, it becomes very difficult for us to know what is this value here and try to use interior angles. Neither can we have a Z shape, okay, to have our alternate angles, right? So we are unable to show that BE and FD are parallel lines. Okay, therefore we abandon that pair, okay, and focus on the other pair, right? I'll take a break over here now, okay, because the next one is going to be circle theorems, and circle theorems is slightly more challenging, okay. So I'll give you all 5 minutes break, okay, until 10 o'clock according to this clock, right? You can go toilet whatsoever. Make sure you come back by 10.
You're gonna pause. You just stop it. Start again.